Okay, we're going to talk about secant lines, tangent lines, and angles um, outside the circle. I know that you already know what tangent lines. Tangent lines are lines that intersect a circle exactly once. Secant lines are new though. Secant lines look like this. Let's draw a circle and do something like that. So you'll notice that a secant line intersects a circle exactly twice. All right, now if you put these two things together, there's three possibilities. So let's look below at the three possibilities. You could have this first case of a tangent line and a secant line making an angle outside of the circle. You could have two tangent lines make an angle outside the circle, or you could have two secant lines, secant and secant, making an angle outside the circle. Regardless of what situation you have, the formula is pretty much the same concept for finding those angle measurements outside the circle. All right, on my copy you can see the color coding pretty well. What we have is, with respect to this angle out here, we have two intercepted arcs, or two arcs that lie in the interior of the angle. So here's the interior of the angle. And there are two arcs. You can see one is red and one is blue. Two arcs that lie in the interior of that angle. We can refer to one of those arcs as the far away arc. So this one right here is far away. And then this other one right here we can call the nearby arc because it is near to that angle. And the formula says that if I want to find the measure of this angle right here, I'm going to take half of the difference of the arc BC, so that's the faraway arc, minus the measure of arc AC, that's the nearby arc. So according to this formula, if I want to find the angle, I can do half of the faraway arc minus the nearby arc. All right, let's look at the second example. In the second example here, I have a faraway arc. I'm going to use the same colors so I'm not being inconsistent. A faraway arc right here. And then I also have a nearby arc right here. And both of these arcs lie in the interior of angle 2. So here's the interior, and the arcs are in the interior. What you'll notice with the tangent problem is that the two arcs actually make up the entire circle. Okay, so when we have the two tangents, for the case of the two tangents, the two arcs make up the entire circle. And that's going to be important later. I just wanted to point it out to you now. Let's take a look at the formula. So to find the measure of angle 2, according to the formula below, it says take half of arc PQR, so that's the faraway arc, and subtract the measure of PR, and that is the nearby arc. So half the difference again, and it is far minus near again. So let's look at the third one. This time you have two secants. Now this time the whole circle is not inside, so we're not going to use this part of the circle, we're not going to use this part of the circle. It's not in the interior, it's not an intercepted arc. It has to be an intercepted arc. Okay, and so we have XY, that is the far away arc, because it's far away from angle 3. And then we have WZ, that is the nearby arc, that is close to angle 3. Let's look at the formula again. So the measure of angle 3 equals half of the measure of xy, again, that's far minus near. So you can kind of see the consistency in the formulas here, that if we want to find the measure of the angle, we're going to take half of the far away arc and we're going to subtract the near arc. Sorry, we're going to take half of far minus near, not half of the far then subtract near. I said that incorrectly. All right, so let's just try a couple examples to see what this looks like. Okay, again, the measure of the angle is 1/2 of the far arc minus the near arc. Okay, so let's look at this picture. I have two tangents. This is a tangent, this is a tangent. And remember, the tangent is that special case where the entire circle is intercepted in two different arcs. So we have a far away arc going from E to G this way, and then we have a nearby arc going from E to G this way. The nearby arc is 113 degrees. Well, with tangents, you could calculate what the other arc is because, again, with tangents, the intercepted arcs make up the whole circle. So if I do 360 and subtract 113 degrees, then I get 247 degrees for the far away arc. And now I'm ready to use the formula. So the measure of angle F is equal to 1/2 of 247 minus 113. I'm going to get my calculator. All right, so if I do 1/2 times parentheses 247 minus 113, then I can find out that the measure of angle F is equal to 67 degrees. And that's how we use that formula. Let's try another one. All right, this time I have a secant and a tangent. So there are two intercepted arcs. One is nearby, and there's another one that starts at S and goes to V that is far away. So the formula says that the measure of angle U is going to be 1/2 times, this is the far away arc, this is the nearby arc, so it's 201 minus 99. So 1/2 times parentheses 201 minus 99 gives me 51. So the measure of angle U equals 51 degrees. All right, I'll work out the rest of the problems in the notes in the next video.